5I1 plus 5I1 plus 5I. And again V1 is equal to 5I1 minus 10I2. What I want? I want a ratio of I2 upon I1. So I should get rid of V1. So I just equate the equations. So this equation is 10I1 plus 5I2 is V1, right? That must be equal to 5I1 minus 10I2. Is it correct? Alright? Or something wrong? So V1 is expressed, again 1 is expressed. So both are equal. So I automatically get rid of V1. So that is 10I1 plus 5I2 is equal to 5I1 minus 10I2. So what I get ultimately, grouping this on the other side, this on this side. So 5I1, is it visible there? This one? This one? This is not visible. It is visible. So we get 5I1 is equal to minus 15I2. 5I1 minus 15I2. So we want I2 upon I1. I2 upon I1 is minus 1 upon 3, right? So H21 is equal to minus 1/3. H21 is minus 1/3. Alright? Or any other answer somebody has got? H21 is minus 1/3, right? Now, other parameters which are made by using I1 equal to 0, which are to be found out by using I1 equal to 0. So how we can find that these two parameters? I1 equal to 0 means this we write 0 specifically. So this is I2. So what this must be? I2 only. It must be I2. So when I would like to give a simple hint. When we are finding the parameters by using some current to be 0 by keeping that port open, what we should do is in Kirchhoff's mesh laws, that port is not to be considered. In Kirchhoff's mesh laws, that port is not to be considered. So you need not worry about what is V1. You need not worry about what is V1. So now we get, this is, means don't connect it in, do not connect anything here. So V2 is here. V2 is here. Now what is H12? H12 is, this gives me H12 equal to V1 upon V2 when I1 is 0. When I1 is 0 means whatever is this voltage must be equal to this voltage. Why? Whatever is this voltage must be equal to this voltage. What is the reason? Because this current is 0. Right? So don't connect any source as such and don't include it in the loop. So V2 if we apply here, so what will be this voltage? What will be this voltage? It would be, so this voltage, but what is I2? So this voltage is, if I can say as something like X, this would be, or if I may point A, so VA would be, this current is not flowing, so 5 upon 5 plus 10 into V2. So there is no need to find I2 also. So VA is equal to 5 upon 5 plus 10 into V2. So VA is equal to V2 upon 3. But VA is V1. So V1 is equal to V2 upon 3. So V1 upon V2. V1 upon V2 is 1/3. So H12 is 1/3. Is it alright? H12 1/3, or somebody has found other answer. Now what? Now H22. H22 is very simple. What is H22? Is the ratio of I2 upon V2. I2 upon V2. What is that?
1/15.
1/15. H22 is 1/15 because since this current is not there, the total current is I2. So V2 is equal to 10 plus 5 is 15 I2. V2 is 15 I2. We can get easily V2 is equal to 15 I2. So H22 is 1 upon 15. H22 is 1 upon 15. Is it clear? So finding any parameters for any circuit is very easy by this method. Then we may go by some brute force method. We will go by some brute force method. That method we apply a voltage X. We apply voltage X. We connect a voltage source with voltage level X to a point, and then we can proceed further. So we find same things by brute force method. That is, first we make V2 0. We make V2 0. So when we make V2 0, what is H11? V1 upon I1. H11 is V1 upon I1. So you connect a battery of X, voltage X. Why voltage X actually? To be more precise, we should connect voltage 1 volt. I think we should connect 1 volt only, and we get the answer. But actually there may be, means these are to be found out for those networks which do not contain. Here we are expressing a linear combination. There may be some situations where it may not be linear combination. That is very complex situation. If we put some source inside the circuit in such a way that there will not be linear combination. But I think that is very exceptional case, so we forget that. And we apply a voltage of 1 volt for all practical purposes. It is not a classical method. It is a method which is easily understood. So apply 1 volt. So what is V1? 1 volt. Then now what is to be found out? I1 is to be found out. What is I1? How will you find I1? Now no Kirchhoff's law, nothing. So this, you forget everything. So how can you proceed? So this voltage upon this current is to be found out. How to find out this current? 10 and 5 parallel. That is 10 by 3. So 5 plus 10 by 3.
25 by 3.
That is equal to
25 by 3.
25 by 3. So current would be 1 upon 25 by 3. 1 upon 25 by 3 is 3 by 25. Current is 3 by 25. Voltage is 1. V1 is 1. I1 is 25 by 3. So V1 upon I1 is 3 by 25. Right? H1 is 25 by 3. V1 is 1. I1 is 3 by 25. So H11 is 25 by 25. Right? Now what about H21? What about H21? Apply 1 volt here. Apply 1 volt here. Then what is you found out now? This current. This current is found, right? How will you find out this current? It current will flow like this. It is 3 upon 25. Right? So here the answer is simple. 3 upon 25 will divide. In what way? 1 upon 25 here. And is it alright? In which way? In this way and this way. So I1 is 3 upon 25. Current is flowing like this. What is I2? Minus 1 upon 25. Minus 1 upon 25. So I2 is minus 1 upon 25. Minus and I. So H21 is I2 upon I1. What is H21? I2 minus 1 upon 25. What is I1? 3 upon 25. So what is H21? Minus 1 by 3. H21 minus 1 by. Right? And next. Next is to find H12 and H22. For that, port 1 should be kept open. So don't connect anything in here. But connect. Connect 1 volt here. What is V2? 1 volt. So now what is you found out? H12. It is what? V1 upon V2. What is V2? H12 is you found out. H12 is V1 upon V2. What is V2? V1 is you found out. How to find out? How to find it out now? 5 upon 5 plus 10. That is 1/3. V1 is 1/3. 1/3 upon 1. That is 1/3. Then what is H22? I2 upon. What is V2? What is I2? I2 is 1 by 50. Is it clear? So by these methods you can find all types of parameters. All types of parameters you can find. Is it alright? Now we want to derive the conversion formula. We have to derive conversion formula is what I say. So now take the task. Derive the conversion formula for converting Z parameters into H parameters. Convert Z parameters into H parameters means what? A circuit is given whose exact composition is not shown to you, but whose Z parameters are given to you. So by using Z parameters of the circuit, you have to determine the H parameters of the circuit. So determine H parameters from Z parameters. Determine H parameters from Z parameters.
Task is given to you.
Is the idea clear? Z parameters are given. From that we have to find out H parameters. So this is no, these four are known. These four are known. So now what we have to do is we have to rearrange these equations by linear transformations. We will rearrange these equations by linear transformations to have these equations. Have suitable linear transformations here to get these equations. So how we will proceed? So I just write simple manipulated equation. I will take this on the other side. Is it correct? The second equation, which was V2 is equal to Z11 I1 plus Z12 I2, I am just taking that on this side and V2 on the other side. So these two I have got at least somewhat. Then this I can divide. So it is minus Z21 upon Z22 and 1 upon Z2. So I am finding that this is as good as correct equation. Is it? I2 is equal to minus something into I1 plus something into V2. This is something which I don't like. This is something which I don't like. In that, this is alright for me, but this I should not have. This I should not have. So how to get rid of that parameter? How to get rid of that parameter? Is it difficult? Use the second equation there. So first equation I can rewrite again as V1 is equal to Z11 I1 plus Z12 into this minus Z21 upon Z22 I1 plus 1 upon Z22 I2. Sorry, V2. And I got just what I wanted. Is it? So I can rearrange. So Z11 minus Z12 Z21 upon Z22 I1 plus Z12 upon Z22 V1. So this is equation 1 and this is equation 2. and I can look that this equation 1 is of the exact form of equation, what we can say, 1 dash, and this is 2 dash. So equation 1 and 1 dash are alike, equation 2 and 2 dash are alike as regards to positioning of the variables v1, v2, i1, i2 are concerned. Is it right? Do you agree with me? Equation 1 and 1 dash and 2 and 2 dash are alike as regards to their positions are concerned. So then very simply you can write h11. What is h11 then? z11 minus z12 z21 upon z2. What is h12? z12 upon z2. What is h21?
minus
Minus z21 upon
Z22.
what is h22? 1 upon.
Z22.
Is it alright? So I hope it is very simple. Just have linear transformation. What is linear transformation? Multiplying the equation by some constant, adding the two equations as they are, or adding these two equations by suitable multiplications, rearranging the terms like this. So convert now x parameter to z parameter. Let us see how reverse you can do. Derive the formula for determining z parameters from known h parameters. You can put pause. Hello. Now we derive between y to ABCD, which we have not done. So y parameters and ABCD parameters. So plus y to v. We want this from this way to convert like what is ABCD now? V1 is equal to and I1. V1 is equal to A V2 minus B I2 and I1 is equal to C V2 minus. Is it correct? Right? Now the equation like this. So minus is taken here only. So B is positive that way. In B you are not supposed to write plus into something. Minus sign is embedded here. As minus sign is embedded here in the matrix, it is for minus I2. So now how can we proceed? So this you can take on the other side. This you take on this side. For looking like second. For or in this it is so I1 we have V2. So just replace like this and we get V1. So first we can write as I1 is equal to Y12 V2 plus Y11 V2, but not complete. And now second we can write as Y22 V1 minus is equal to y2 to v2 minus I2. So if you look at this equation, y2 to v1 minus y2 to v1 is minus y2 to v1 is y2 to v2 minus I2. So it is looking like this. So here you can divide by this. When you divide by this, you get a and b immediately. You get a and b immediately. And in this, what you want to get rid of? You want to get rid of this v1. So just you put this. When you get v1 from this, you put it here. So you get the remaining. See, is it right?